So today's topic is, I'm calling this Introduction to Pottery Kilns, and this is actually the third part of a three-part series that we've been doing. I wanted to do a series talking about all the different kinds of kilns. So we started 2 months ago with we talked about wood-firing kilns and insulating and coal attached to that, and then we did a session on gas firing, and so this one's going to be an electric kiln.
Welcome to the Potter's Roundtable, a monthly podcast where we share our passion for the ceramic arts and a collection of topics specific to potters. Remember to subscribe so you don't miss a single episode. Enjoy the show.
I haven't decided what we're going to do next month, but it may be something related to issues that are related to firing, like firing problems. Because when you fire kilns, there are issues that you have with actually operation of the kiln. Some of them show up in the work and could cause problems with the work. Others don't really affect the work directly. They just are problems with operating the kiln. So I thought I might do a topic on that next month, where we talk about problems in operating the kilns and things that actually show up as defects or problems with the work themselves. The other thing I wanted to mention is that all of these three discussions have been really attempt to be an overview, because I realize that not everybody has the same background in ceramics, and some people, for instance, have never fired a gas kiln or worked with a gas kiln or wood firing. So it was meant to be an overview, kind of an introduction, so that if you wanted to learn a little bit more about this maybe would give you a little information on the different firing techniques. Today this is still going to be somewhat of an overview, but if you have, very specific questions, please ask them. I mean, we love questions. So, and one of the purposes, I think, of a lot of these sessions that we try to have is to solve problems. I mean, to me, that's the whole reason for doing all this technical stuff, is that aside from just the intellectual part of it, it's kind of fun to know what's going on. But a lot of the problems that are associated with pottery have to have a technical basis. And so if you understand a little bit of the chemistry, a little bit of the mechanisms that are going on, you can solve the problem. So to me, that's really what the importance of the technical part is. If you know some of this information, it frees you to be creative. You're not constantly tripping over the fact that your pots are blowing up or the glazes are always running, and you can focus on the creative aspects and not worry so much about the mechanics of the process. So to me, that's the real value of a lot of this technical background information. So to get started, I guess basically just by way of review, what is a kiln basically even? How do you define a kiln? A kiln is basically an enclosed space for heating, if you want a definition. And you might say, well, why do we need kilns? Well, for one thing, one of the big things that you need a kiln for is control. By having an enclosed space, you're able to control what's going on within the space, ideally. That's the goal. And also, you need the enclosed space to achieve high temperatures. When we talked earlier about, when we did the wood firing session, we talked about some of the really primitive kilns that were all the way from just a bonfire to really rudimentary enclosures. They have very poor temperature control, too many things that, wind blowing over it and the weather can affect it. So they had poor control, but they also couldn't achieve high temperatures. So it's really for those two purposes. It gives you control, which you need for reproducibility, and it also gives you, it enables you to reach high temperatures. So, but as I say, as we go along, if you have any questions, please just interrupt me with the questions, and they can be on anything. The meaning of life, how do you fix your '72 Volkswagen? I don't care. I may not know the answer, but we can talk about it. Okay. Okay. So, just a little bit of history. When you think about it, electric kilns really haven't been around that much at all. I mean, in the 1920s. A big part of the United States didn't even have electricity in terms of, people's homes. Electricity only became common in people's houses in the 1920s and 1930s. There was a huge proportion of the population that didn't have anything. So electric kilns really only started to become useful and popular and common really in the 1950s and 60s in terms of, what we would call hobby kilns or, kilns for like ceramists or studio artists. Industry had been using them before then, but they were still pretty rudimentary. And one of the things that made electric kilns, when they first started appearing practical, was better insulation. Because the traditional bricks that you build kilns out of for wood firing or gas firing or coal, all the traditional bricks, were these hard, dense bricks. And they're terrible. They're strong, but they're terrible insulators. And I'll pass these around just for comparison. This is a typical sort of traditional dense or hard fire brick, and it's heavy and it's strong and it's durable, but it's a terrible insulator. And so one of the innovations that made electric kilns a lot more practical was when they started developing better insulation. Also, there's a general principle with kilns that the smaller the kiln is, the less efficient it is. Because the smaller it is, the more heat it's going to lose, and the more energy you have to put into it to keep it to get hot. It loses heat faster. So bigger kilns actually retain heat longer. So I'll pass these around. These are about the same size, and you can feel the difference in the weight. So this is an insulating kind of fire brick. It's called IFB, insulating fire brick. And it's lightweight. It's not very strong mechanically, but it's a pretty good insulator compared to the normal fire brick. So you can just see the difference in the weight. And so one of the things this enabled us with the better insulation came along was now we can make kilns that are portable. They're not these monstrously heavy things. We can actually make things that can, even in an industrial setting, they can be moved around if they have to. Or it led to the forms that we have today where you can literally, you break them down in sections and you can pick them up and move them. Well, it wouldn't have been possible without this lighter weight of brick. But there were other forms of insulation that also were developed. There was an early form of sort of fiberglass insulation called rock wool that was actually used in houses. Well, and it was sort of a dirty, fuzzy kind of ceramic fiber, and it was actually spun from slag. They took slag from the steelmaking industry and it was spun into fibers. And it was sort of nasty, dirty stuff, but it still was pretty good insulation. It was like an insulating blanket. And so that was another kind that they developed. And then the more modern version, I'm going to pass this around just so you can see it. I don't know whether you've all seen Kea wool or insulating fiber blanket. This is just a sample of it, but this is really lightweight insulation. We don't use this kind so much in electric kilns that we use because it's not really sturdy. You can't build a kiln out of it. You can line a kiln with it. And so industry uses this a lot. It's really good insulation, really lightweight, and of course makes it, very portable. But it's not suitable for the kind of kilns that we use, just because it's not very strong.
What's that called?
This is called, it's ceramic fiber, basically, or fiber blanket. So anyway, one of the things that enabled these smaller kilns to be built and the portable kilns that we know today is the fact that they're the better insulation. Okay, the other thing is the first really, if I want to call them non-industrial or hobby kilns, they appeared kind of in the 1950s, and they didn't even really get going until the 1960s. And these were really simple designs. So you can see the kind of kilns we're using today have not been around that long at all. And then more recently, they've developed larger kilns, different designs have become available. We have kilns now with more sophisticated features like electronic controls, which they never used to have. And we've continued to evolve better materials. So now we have kilns, for instance, where the actual materials that the elements are made out of are much better than what they originally were. We'll talk a little bit more about this. So the overall construction and even materials in the kilns have gotten a lot better. So a little bit of background. So when you're heating with electricity, basically what you're doing is called resistance heating. And what this means is when you pass an electrical current through some material, some metal, and unless it's a really great conductor of electricity, it resists the passage of electricity. And so when you try to pass the electricity through it, it doesn't want the electricity to go through it, and the result is the material gets hot. So a lot of times we don't want that. And certainly, you don't want the wires and the walls of your house to get hot when you pass electricity through them. So we use materials that conduct electricity really well, like copper. But for a heating element, we purposely pick a material, a metal, that does not conduct electricity really, really well. It gets hot. So actually, what in some situations would be a defect, we're actually taking advantage of that here to heat up our kilns. We pass an electricity through a wire, and the wire resists it and gets hot. The electricity still goes through it, but it gets hot in the process, and then we use that to heat our kilns. And just in case you haven't seen one close up or you haven't handled one, this is a brand new element, and before they're used, they're sort of springy. We'll talk about the shape later, but they're just basically, sort of metal wire, in this case, wound So the heating elements get hot when you pass through when you pass the electricity through, and the elements are and all the electric kilns that we're familiar with, these coils of the wires run along the walls of the kiln. They have to be supported, so they run along the inside walls of the kiln. One of the reasons why you might say, well, if they're wires, why are they coiled up like this? Well, for a couple of reasons. It could be just a straight wire. But one of the reasons is that it takes up less space, because in order to get a certain amount of heat, you need a certain length of wire to generate the heat that you want. And so in order to fit that amount of wire into the kiln, they coil it up to take up less space. There's no reason why it couldn't be straight, and you could run it 37 times around the kiln, but it takes up less space, and it's easier if you just run it into coils. That way you have the total length of the wire that you need. But also, by coiling it, you concentrate the heat. By having more of the wire close together, in each little area, more heat is given off, rather than if the wire was straight and strung out over a longer area.
Bill, is it important what metal?
Okay. And so the two metals that are used, yes, there are two common types of metals. One is called nichrome, Nichrome. I feel like I'm writing with a telephone pole here. Nichrome. And this was the original form of heating element wire. And it was patented actually in 1905, this metal combination. And it's a combination of iron, nickel, and chromium. It's an alloy, but it's really cheap. So it was a great invention when they discovered it. And of course, if you think about it, if I'm going to make a heating element, it has to be something that can get hot, but won't melt. Because a lot of metals, if I got them as hot as the kiln is, the wire would melt. So I have to get something that will resist electricity, but also not melt, so that it can still be there to give off the heat. And this was one of them, nichrome. It's limited to about 2,000 degrees Fahrenheit, roughly, in terms of use. And you can take them to higher temperatures, but then they burn out, basically. The lifetime decreases a lot. So when electric kilns were first produced, nobody was going to cone 10 with an electric kiln. They were all really doing mostly earthenware, low fire ceramics. So these were fine for that. And they're still used in low temperature kilns because they're really inexpensive. They're cheap to replace. They're great. They're limited. Then there was a whole family of new kinds of metals developed called Kanthal, Kanthal. This is a company name or brand name, kind of like Kleenex or Scotch tape. Kanthal is their company's name. These are introduced in the 1930s, and these are a different kind of alloy. These are iron, aluminum, and chromium, if you're interested. And the advantage that these have several big advantages. They can go to a lot higher temperatures. They don't burn out, which means they don't burn out as easily. But also, when you fire these, the metal in the wire actually develops a coating of aluminum oxide that protects it from fumes and acids and things in the kiln. So when you use the element, it actually develops its own protective coating, which the nichrome doesn't. So, and as you're probably aware, when you fire any kiln, there are fumes coming off in the kiln, coming off from the clay, like when you're bisque firing or even when you're glaze firing. And some of those fumes are extremely acid, and they can actually eat up, they attack the metal. So they can easily attack a nichrome wire. These are pretty good, pretty resistant to that because they built up this protective coating. So these now they're a lot more expensive, but it's a considerable advantage in terms of lifetime and resistance to these fumes and wear and tear compared to the old nichrome. And they go to a lot higher temperatures, so you can go to cone 10, 11, 12 with these things.
If you were to rewire your kiln with one of these, would you recommend then like firing it up empty without putting?
You're absolutely supposed to. Not just me recommending it. You're supposed to do that. Yeah. If you put in new elements, what you're supposed to do is before you expose the elements to the fumes from the clay, you're supposed to do an empty run with the kiln. You can put shelves in, but it doesn't matter. But basically, you want to preheat the elements. So you do a bisque firing, essentially, with nothing in the kiln. And when you do that, it builds up this oxide coating, and it'll extend the life of the elements. So it's a good point. They really recommend that.
If you were to, like, say, replace your elements with the Kanthal, would you see a difference in like your segments, like the heating times in your segments, because like they heat at a different rate, like the Kanthal versus the nichrome?
I'm not aware of any, personally, I'm not aware of any kilns where we replaced Nichrome with Kanthal. Because usually, like if you have a kiln, let's say that's capable of going to cone 10, like a lot of kilns are, it wouldn't come with Nichrome in it.
Okay, so most of them don't have that, the newer kilns now.
Almost all the kilns now, no, unless you buy one of these small tabletop kilns that are used for like jewelry making or enameling, or it's specifically an earthenware kiln, like limited to, earthenware low fire, they almost all come with Kanthal. And the answer to your question is, I was evading your answer. The answer to your question is, yeah, it might change the characteristics a little bit. It might.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.
Yeah, that was one of the issues I think we had at the middle school, is as the coils were getting older, the elements were getting older, it was taking a long time to reach temperature, and after they replaced some of the elements, then it was firing at the appropriate time.
And that's a common characteristic of all elements. As the elements age, this is one of the symptoms of elements aging, is that the kiln takes longer and longer, and that doesn't matter whether it's Nichrome or Kanthal. As the elements get age, the resistance of the element increases. So with the same power going through, it doesn't get as hot, and it takes longer to get hot. So that's one of the common signs that your elements are aging. Yeah.
What causes aging? Is it firing or is it time?
No, it's firing, it's temperature. And so the resistance of the elements, one of the things that happens is, since they're being fired in air, a lot of the chain, like if I'm looking, this is the cross section of the wire, the air is hitting the wire from the outside, and so the air is attacking the wire basically. So the part of the wire that can still conduct electricity in the inside of the wire gets smaller and smaller and smaller, and you get these oxides and deposits built up on the outside. So the core of the wire that can still conduct electricity gets smaller and smaller, and as it does, the resistance increases.
Is that why they tell you to change all the elements at once? Even if you just have one go, do you change all of them?
Well, it depends on how old the rest of the elements are. If the rest of the elements have a fair amount of age on them, and let's say an element goes, and I say, this is probably the first of all the elements, they're getting to the point where they're all going to start to go, but this is the first one, then I replace them all. If something goes accidentally, where I still think I have a lot of lifetime, but maybe something breaks or I get a short for some reason, then I just replace the one.
Yeah, because I was having a problem with just one particular one. It was like the thermocouple in that section and the wire. It was like everything. Yeah. It was like in a certain section, but everything else, and it wasn't that old. You know what I mean?
No, it's not a problem. You can replace if there's still a fair amount of lifetime. Then I only replace the one.
Now, if you just do the one, do you still run a bisque fire ahead of time?
Oh yeah. You still want to break in, because the point is, if you start using that element and you haven't built up that protective layer, then it'll get attacked. Now it's not going to burn it out, but it can shorten the life. So to get the maximum lifetime out of it, if you do a bisque or something where you build up that protective layer, then you'll extend the life. You'll get the maximum lifetime of the elements. Okay? Yeah.
So I've also heard if you're rushing the load and you put greenware in that's slightly wet, and then you candle it first, that can affect your lifetime of your elements. And then also sometimes I do fire with cardboard, armatures and different things in there, and I heard that can affect the elements.
Yeah, it can attack them, but this is one of especially in Nichrome. But this is one of the advantages of the Kanthal, is that if you build up a protective coating on the wires, then they're much less sensitive to the water coming off or to the carbon and the fumes coming off from burning it. Much less. You still don't want to, they still said you don't want to try to do reduction in an electric kiln, like put a lot of combustibles in there, because even with this protective coating, when the coating expands and contracts and cools down, it still has cracks in it, so it's not totally impervious. So if you overload the kiln constantly with a lot of, by burning things in it, yeah, you're still going to shorten the life of the elements. You're still going to do it. But, because again, the coating isn't absolutely perfect. It has cracks and little defects in it where fumes can still get into it. But it's still a lot better than no coating. But yeah, but occasional, I'd say, you know what also helps? And do you have a downdraft fan on your kiln?
Yes.
Okay, because we'll talk more about this later also, but if you have the kind of fan now that you can mount on a kiln where it draws air in at the top and withdraws them, that really extends the life of your elements. Because now you're pulling those fumes out of the kiln and they're not sitting there just, you know, cooking on your elements. Yeah?
When instructions say that you have to leave a little bit open for at least a couple hours, is that helping too?
This is on the lid of the top of the kiln?
Lid.
Well, do you have on your kiln, well, you're getting a kiln, right?
Yeah, I have this kind, like small kiln.
Okay, but if you have one of these downdraft fans that I'm talking about, do you know what I'm referring to with these fans? Okay, well, we'll talk about, if you have one of those, you don't need to leave the lid open.
You're not supposed to, right?
No, you're not supposed to. But if you don't have to have one of those fans, but the idea is there are two things you want to do. You want to get the fumes out of the kiln, excuse me, and then you want to get the fumes out of the room. So the nice thing about these downdraft fans is they do both. They pull the fumes out of the kiln and pass them outside, whereas you're right, though, to get them out of the kiln, you can leave the lid a little bit and also leave the plugs and the peepholes open, and you do both. And so typically, you might leave those, like when I was doing bisque firings in an old kiln, I had a kiln that went like low, medium, high. So on low, I'd have the lid propped up for an inch or so, and I'd have all the plugs out. And then on medium, I'd put the lid down, but I still had all the plugs out. And then when I turned it to high, I had the two bottom plugs in and the top one still out for a bisque firing so that the fumes could get out. And that'll extend not just the life of your elements, that extends the life of the bricks of the kilns. The fumes that come out of the clay actually attack the bricks on the kiln. And if you've ever seen a really old kiln, and the weird thing is they attack the bricks from the outside in. The bricks that are next, that's because the fumes that come out of the kiln, it's sulfur oxides, and when they hit the moisture in the air, they form sulfuric acid. So the fumes come out, work their way through the bricks, and when they get to the outside of the bricks where the air is with the moisture, it forms an acid. So they actually attack the bricks from the outside in.
Is that why you sometimes see like that corrosion on top of like your digital controller?
Yeah, that's all the stuff coming out of the, yeah. And you see it around the joints, and you see it on the hinges, yeah, or the handle that hangs over a peephole. Yeah, that's all, because it's sulfuric, it's battery acid. It's the same acid that's in your car battery. It's a really strong acid, which is also why if you've ever smelled the smell of a bisque firing in particular, it's that kind of acrid, almost metallic smell, and it kind of, you can feel it in the back of your throat and your nose. It's battery acid.
Okay.
Okay? Yeah.
Boy, potters are weird.
If you fire metal with your clay, like say you like to put nails in the clay.
Why would anybody want to do that, Jane?
Because it's cool.
No, I'm kidding.
Does that also affect the wires and the bricks?
Not that much.
Oh, really?
Not that much. I mean, if you did a kiln load of metal parts in there, yeah, you might produce some fumes or something that could attack it, but a little bit occasionally. Especially the downdraft fans have really eliminated a lot of the wear and tear on elements because they don't let the fumes just kind of sit in there.
So are we talking steel, ferrous, metals, or aluminum? Or?
It's going to be mostly something where you might get some actually vaporization, so like copper, something like that, where you might get a little something vaporizing. Steel, probably not. You're just going to oxidize it. Okay. And iron, you're just going to oxidize it. You're going to sit it.
Might harm the wires and the bricks?
Not significant, and I wouldn't say significant. Unless you put, you had the whole thing filled up with stuff made out of copper, I'd say no. Okay. That's not an issue, really. It's not an issue. Yeah?
What else can make your kiln tell you that it's firing too slowly, besides number of firings?
You mean what can cause it to do that? Or
yeah. I have a kiln that doesn't get fired very often.
Mm-hmm.
And the last time I fired it, toward the end, it had this error code on it that said it was firing too slowly.
Is it a manual control kiln or is it electronic?
Electronic.
It could be the thermocouple also. because the thermocouple has to be replaced. Because if you have we'll talk more about this, but if you have an electronic controller, that operates by means of a temperature measurement device called the thermocouple. And the thermocouple ages similar to the way the elements can age. So if the thermocouple isn't reading correctly, the elements may be working fine. And so, but in order to, the controller is based entirely on what the thermocouple is telling it the temperature is. And if it's not reading properly, it could also be the thermocouple. Now, the other thing it can be also, sometimes, depending on how big your kiln is, it could be that one of your elements isn't working at all. Excuse me. So it might not be that the elements are heating up slowly. It could be that one or more of them isn't working at all, in which case you're not getting enough heat in the kiln, and the kiln will heat up slowly. So one of the other things to check, if you say, well, gee, my elements aren't that old, then one of the things to check is, are all the elements in fact heating up? Because there's nothing that says that occasionally, I've seen new elements occasionally burn out. There could be a little defect in the wire. I mean, it's rare, but it can happen, or something can happen where the element burns out or it's not operating. So the other thing to check is, are all the elements functioning? Are they just getting hot? And if they're getting hot, then you say, okay, then maybe they're getting hot too slowly.
One of the things that the instruction manual said to do in that was to vacuum it.
Oh yeah, well, we're going to talk more about this later, but I'll just mention that. Yeah, something you want to do is you want to vacuum, at least once a year, I'd say, you want to vacuum out the element grooves. So if you take a vacuum cleaner, you know they have those soft sort of little round brushes that you can like brush Venetian blinds and things with, is run that along the inside of each groove and suck the dust out of the grooves, because the dust that accumulates in the grooves, if it gets between the coils and the wire, it can actually produce a short. And you can actually shorten the life. And so occasionally you'll see an element where the element will arc and it'll burn out. And some of that is accumulated like this debris that accumulates in the coils. And this is especially important if you ever do a bisque firing and the bisque ware blows up and blows shards all over the kiln. When that happens, you should definitely vacuum out because you've probably blown little pieces of ceramic into the grooves where the elements are. And you can really
vacuum after every bisque fire?
No, only vacuum when you blows up. But in your case, yeah, I would say that, yeah, for sure, yeah. Everyone then, Dennis, yeah.
If you don't have it blowing up, what kind of frequency?
At least once a year, I'd say, at least.
Okay.
At least once a year. And I do it or every 6 months. I mean, the one thing, we'll talk about it later, but there's so little maintenance on an electric kiln, and it takes 10 minutes to vacuum out the thing, so it's worth it.
Well, sometimes I do it more than that.
Yeah.
You said, I had one arc, and thank God it was on a bisque load.
Yeah.
Because you're in there and you're like, why are these brown flecks all over my
Yeah.
And it was the coil, and I would just straight through.
And there's a good chance that could be caused by debris that gets in the channel. Yep. Okay. So let's just talk briefly about electric kiln construction and design. Basically, for pottery studio kilns, there are really two main shapes, as you're probably aware. There's what basically looks like a box. And they're either top loading. The older type looked sort of like a chest freezer. You've probably seen some of the older ones. Big, heavy, thick walls, and the lid lifted up. That was also, those were some of the earliest ones because that was before they even perfected some of the better insulation. So they weighed a ton, and you literally lifted the top lid up. That was about 6 inches thick, and you loaded it from the top. And now they've made ones now where they have a door that opens on the front loading, but they're basically a box. And they have slightly larger versions that are called car kilns or shuttle kilns. And so instead of having a door, they stand on the floor. You'll actually have a trackway, and there's a rolling car that rolls in that has part of one of the walls on it, and it rolls in and rolls out. But it's still basically a big box. The kind that we're probably also maybe more familiar with are what some people call a barrel kiln. They're oval. If you look down on them, they're round or they're oval in shape, and those are all top loaders. And they also, all of these kilns that we use, they have what the firing schedule is called intermittent or periodic, which means that we turn them on and off. Because not all kilns are fired like that. Industrial kilns, they have larger boxes, basically, and they have larger car kilns and shuttle kilns, but they also have tunnel kilns that are never turned off. And so they might run the kiln for a year or two, an electric kiln, and never turn it off. And it's a big, long tunnel, and they shove the pots in one end and take them out the other, and there's a belt or a track that moves through the kiln. And they put the pots on the belt or the track, and it moves through the kiln and comes out the other end. And so they never turn the kiln off. And that's called continuous firing. And we don't use those in studios, but in high production facilities, that's the norm, because they 24 hours a day they're putting pots through the kiln. What this relates to also is the fact that there's a limitation on the size that you can make an electric kiln to be practical. Because if you think about it, let's say I wanted to make this room into an electric kiln, and so I hang elements on the walls. If all the heat is coming from the walls, it's going to take a long time for the heat to reach the center of the kiln. Especially if this room was full of pots, it's going to take forever for the pots in the middle to get hot. Because unlike a gas kiln or a wood kiln, there are no hot gases moving through the kiln that's bringing the heat to all the pots. It's strictly the radiation coming from the elements. So there's a practical limit to the size, the cross-section of the size you can build electric kilns, because otherwise it just takes forever, and it's really inefficient. The pots on the outside of the elements would get fried long before the pots in the center even got warm. So the solution to that, this is why the tunnel kilns are a solution to that. They can make very little narrow kilns, and they can be a quarter of a mile long, but they're very efficient heating. And this is why electric kilns, unlike gas kilns and wood kilns, there's a practical size limit. We know that this was a lot of information in a short period of time, so if you want to hear it again, listen to our podcast version of the presentation. Search for the Potter's Roundtable on your favorite podcast platform.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.